Twist-on wire connectors are indeed listed and marked for conductor suitability. This means that when you purchase these connectors, they should have markings that indicate the types and sizes of wires they are designed to connect safely and effectively. Several aspects contribute to understanding this suitability. Firstly, the underwriter's laboratories all listing is crucial. UL is a nationally recognized testing laboratory that evaluates products for safety. When a twist-on-wire connector is UL listed, it means it has been tested to meet specific safety standards. The UL listing will often be indicated by the UL symbol on the connector packaging or the connector itself. This listing assures users that the connector has undergone rigorous testing to ensure it can perform its intended functions safely under specified conditions. Secondly, markings on the connectors are equally important. These markings provide essential information about the connector's capabilities. Typical markings include the wire gauge range the connector can accommodate, the maximum voltage rating, and the type of conductors the connector is suitable for. For example, a connector might be marked for use with 14 to 10 American wire gauge, AUG, solid or stranded copper conductors, and rated for up to 600 volts in building wiring or 1000 volts in lighting fixtures and signs. It is critical to adhere to these markings to ensure a safe and reliable electrical connection. Thirdly, conductor compatibility is a primary concern. Twist-on-wire connectors are generally designed for use with copper conductors. Using them with other types of conductors, such as aluminum, can lead to corrosion and connection failure due to dissimilar metal reactions. Some connectors are specifically designed and marked for use with both copper and aluminum conductors, but these are specialized and must be used accordingly. Always check the connector's markings to verify its suitability for the specific conductor material being used. Fourthly, proper installation is paramount. Even if a connector is properly listed and marked, incorrect installation can compromise its safety and effectiveness. Ensure that the wires are stripped to the correct length as indicated by the connector manufacturer. The stripped end should be clean and free of any nicks or damage. When twisting the connector onto the wires, apply firm and even pressure until the wires are securely twisted together within the connector. Avoid over-tightening, which can damage the wires or the connector. Fifthly, National Electrical Code (NEC) compliance is essential. The NEC provides guidelines and requirements for electrical installations to ensure safety. Section 110.3 B of the NEC requires that all equipment, including wire connectors, be installed and used in accordance with the manufacturer's instructions and listing requirements. This means that you must follow the manufacturer's recommendations for wire sizes, conductor types, and installation procedures. Failure to comply with the NEC can result in code violations, safety hazards, and potential liability. Sixthly, wire gauge range is a crucial factor. Twist-on-wire connectors are designed to accommodate a specific range of wire gauges. Using a connector with wires outside of its specified gauge range can result in a poor connection. If the wires are too small, they may not make adequate contact with the connector's internal elements, leading to loose connections and potential arcing. If the wires are too large, they may not fit properly within the connector, making it difficult to achieve a secure connection. Always select a connector that is appropriate for the wire gauges being used. Seventhly, voltage rating is another important consideration. Wire connectors are marked with a maximum voltage rating, which indicates the highest voltage the connector can safely handle. Exceeding this voltage rating can lead to insulation breakdown, arcing, and potential fire hazards. Ensure that the connector's voltage rating is suitable for the application in which it is being used. For example, in typical residential wiring, connectors are often rated for 600 volts, which is adequate for 120 volts and 240 volt circuits. However, in industrial applications with higher voltages, connectors with higher voltage ratings may be required. Eighthly, environmental conditions can affect connector performance. Wire connectors are typically designed for use in dry, indoor locations. Exposure to moisture, corrosive chemicals, or extreme temperatures can degrade the connector's materials and compromise its performance. If connectors are to be used in harsh environments, special connectors designed for those conditions should be selected. These connectors may have features such as corrosion-resistant coatings, watertight seals, and temperature-stable materials. Ninthly, stranded versus solid wire compatibility matters. Most twist-on-wire connectors are designed for use with both solid and stranded copper wires. However, it is important to ensure that the connector is properly listed for the type of wire being used. Stranded wire is more flexible than solid wire, which can affect the connection's mechanical stability. Some connectors are specifically designed with features to enhance the connection with stranded wire, such as serrated internal surfaces that grip the strands more effectively. Tenthly, reuse and limitation should be considered. Twist-on-wire connectors are generally intended for single use. While it may be tempting to reuse them, doing so can compromise their reliability. Each time a connector is used, the internal threads and gripping surfaces can become worn or damaged, reducing their ability to provide a secure connection. Additionally, repeated twisting and untwisting can weaken the wires, leading to potential failure. It is always best to use new connectors for each connection to ensure a safe and reliable electrical system. 11thly, visual inspection is a good practice. Before and after installation, visually inspect the wire connectors to ensure they are in good condition. Look for any signs of damage, such as cracks, melted plastic, or corrosion. Also, check that the wires are fully inserted into the connector and that the connector is securely twisted onto the wires. If any issues are detected, replace the connector immediately. 12thly, testing the connection can add a layer of safety. After installing the wire connectors, it is a good practice to test the connection to ensure it is properly made. This can be done using a simple continuity tester or a multimeter. A continuity tester will indicate whether there is a continuous electrical path through the connection. A multimeter can be used to measure the resistance of the connection, which should be very low. If the resistance is high, it indicates a poor connection that needs to be addressed. 13thly, documentation is a valuable tool. Keep a record of the wire connectors used in an electrical installation, including the manufacturer, model number, and specifications. This documentation can be helpful for future maintenance and troubleshooting. It can also be useful for ensuring that the correct connectors are used for specific applications. 14thly, proper storage can extend the life of connectors. Store wire connectors in a dry, clean environment away from extreme temperatures and direct sunlight. This will help prevent degradation of the connector materials and ensure they are ready for use when needed. 15thly, ongoing maintenance matters. Periodically inspect electrical connections to ensure they remain in good condition. Look for any signs of loose connections, corrosion, or damage. If any issues are detected, address them promptly to prevent potential safety hazards. 16thly, consider using alternative connection methods if necessary. While twist-on wire connectors are suitable for many applications, there are situations where other types of connectors may be more appropriate. For example, terminal blocks, crimp connectors, or push-in connectors may be preferred for certain types of wiring or in environments where vibration is a concern. 17thly, stay updated with codes and standards. Electrical codes and standards are constantly evolving to address new technologies and safety concerns. Stay informed about the latest requirements and recommendations to ensure that your electrical installations are safe and compliant. 18thly, consider professional training for electrical work. If you are not comfortable working with electricity, it is always best to hire a qualified electrician. Electrical work can be dangerous, and it is important to have the knowledge and skills necessary to perform it safely. Professional electricians have the training and experience to ensure that electrical installations are done correctly and in compliance with all applicable codes and standards. 19thly, selecting the correct size of the twist-on wire connector is critical. Manufacturers typically provide charts that show the number and size combinations of wires that each connector can accommodate. Overfilling a connector can lead to loose connections and overheating, while underfilling can result in the wires not being securely held. Always consult the manufacturer's data to ensure the connector is appropriately sized for the intended application. 20thly, understanding the color coding of twist-on wire connectors can also be helpful. Different colors often indicate the range of wire sizes that the connector is designed to accommodate. For example, blue connectors might be used for smaller wire sizes, while orange or yellow connectors are used for larger sizes. This color coding can help quickly identify the correct connector for a particular application. Lastly, when dealing with aluminum wiring, special precautions are necessary due to the metal's properties. Aluminum expands and contracts more than copper with temperature changes, which can lead to loosening of connections over time. Additionally, aluminum oxidizes rapidly when exposed to air, forming a non-conductive layer that can increase resistance. Therefore, when connecting aluminum wires, it is essential to use connectors that are specifically listed and marked for use with aluminum. These connectors typically contain a corrosion inhibitor that helps prevent oxidation and maintain a good electrical connection. Furthermore, it is crucial to follow the manufacturer's instructions carefully when installing these connectors to ensure a proper and reliable connection.